good stuff by that. Okay, so just bear with me, as it always takes time for me to do all that. Okay, so last week we had 6.1, 6.2. I did give you notes, kind of, right? And I did give you a video, kind of. I know it's not the same. All I did was I just, took a picture with my cell phone and did a video like that. If I have time, I'm going to go back and show you some stuff from 6.1 and 6.2. However, in doing that, I'm going to go faster than I normally would. I did expect you to try to figure out some of that on your own. Again, last week was not supposed to be a holiday or vacation. I wanted you to try 6.1, and I did my best effort to give you 6.1 and 6.2 in terms of notes and also a less than satisfactory video, but that's what I'm aimed for. Okay, so I'm going to go on to 6.3. So the schedule is still intact. 6.3 today, 6.4 Thursday, 6.5 on Tuesday, and the next exam is scheduled to be on the 24th, covering Chapter 6. Okay. And a reminder of the adjusted homework assignment. Okay. And again, I mentioned, I'm noticing that some of the problems that I give may not match yours exactly. I seem to have a different edition. I apologize for that, but I'm not, there was nothing I could have done about it. That's the book I was given. And some of you were mentioning, hey, the problems don't match. Okay. The main thing, of course, is that you learn the material. I mean, your option number one is, okay, I can't deal with it, forget it, I'm going to drop the course. I don't advise you to do that. Okay. The best option, I think, is, okay, as I do my problem 7, it may be your problem 9, or it may not show up at all. The main thing is that you're learning the material. Okay. So I happen to choose a problem, and you find out, oh, I don't see it anywhere in the book. That's okay. I mean, that's not atypical for teachers in general to pick problems that are not directly out of the homework. I happen to have picked most of my problems from the book, and so if I happen to pick a problem that's not in the book, or I thought it was in the book, but it turns out not to be, well, welcome to the club. That's what most teachers do. Most teachers lecture not choosing problems directly out of the homework. Okay, so be that as it may, the adjusted assignment is 6.1, just 1 to 12, so forget everything else. 6.2, 3 to 14. Okay. Again, if your problems don't quite match mine, that's okay. You say, what about when I turn into homework later? Don't worry about that. I just look overall. Does it look like you did the problems, whether it's my edition or your edition or any edition, you did the homework. And so if I give you a problem which is not from your assigned list, it's very similar to it. It's just like it. So the main thing is that you're getting the knowledge. Right? So that's the key to deal with. Okay, so I'm going to start off lecturing 6.3. Okay? So again, from here on out, it's pretty much one section a day, right? So one section, one day, all the way through, and all the way through the course pretty much. Okay? If I end up doing a problem and you say, hey, my problem doesn't match yours, that's okay. You're still learning the material. The formulas are still the same. The material is the same, so still learn it as work. Or maybe you might find out, hey, my problem 7 turns out to be your problem 9, or my problem 6 is the same as your problem 8, or whatever. Okay, but that's okay. We're still learning the material. All right, so I'm going to start lecturing on 6.3. I'll do, it was 5 to 12. I'll do the evens. And again, my evens may not match yours. And then I'm going to try to go back and more rapidly do 6.1 and 6.2. So I'm not going to go as slow as if you never saw it. I am going to assume maybe you looked at it on your own. You tried the homework problems on your own through the the attachments I gave you and also the little mini video that I gave you. And it may not have been satisfactory, but that's what I'm aiming for. Okay, so let's go to 6.3 now, please. And there's one formula that you need for that. Okay, 6.3, something called the future value of an ordinary annuity. Here's the formula. You don't really need that middle thing there. So I'm going to cover that middle thing. Okay, S is equal to R times the super big fraction, 1 plus I to the nth power minus 1 all over I. Okay, so what you need is S. Okay, and a lot of these symbols stand for the same thing as in section 2, which actually helps. S is a future value of an annuity. S is equal to R. That's periodic deposits. That's the deposit. That's sort of like the principal, but it's not quite the same. It's a periodic investment. It's an investment you make every period. And then parentheses, 1 plus I to the n. And this I and this n are the same I and n as section 2. So if you understood what happened in section 2, it's the same thing. I is divided up into so many pieces. N is the total number of periods minus 1 divided by I. And yes, that I is the same as that I. So again, you don't need this. S is equal to R times 1 plus I to the n minus 1 all over I. That's the only formula you need in section 3. Yes, there's lots of other formulas. You don't need them. Okay? In fact, all the sections have a lot more formulas. I'll only give you what you need in each section. Okay, so that's all you need for this section. Okay, a little bit of background and theory as what's going on here for something called an annuity. Okay, so in section 2, it's still compound interest, by the way. Section 2 was compound interest. Okay, so you plunk down a certain amount to the banker. That's called principal. You plunk down, I don't know, $10,000, $20,000, and it's compound interest, right? And you don't do anything else. You just let it grow for X number of years. Okay? Quite often, you cannot do that. Maybe I cannot do that. So you say you deposit $10,000. Maybe you can't afford to plunk down $10,000 or $20,000 all at one time, but you can invest in something called an annuity. I myself have an annuity. Okay, so what happens for an annuity is this. You don't just go to the bank and plunk down $20,000 and say make it grow. A lot of us can't do that. But you can invest a modest amount, let's say every month. Okay, I actually have that myself. Okay, so I have a certain amount taken out from my paycheck at City College and also from my paycheck at College of San Mateo. Okay, so I get paid monthly. A lot of you get paid monthly. And then something modest, let's say, okay, every month take out $200 or $100 or $50 or whatever you feel like you can afford, right? So every month from that paycheck, I will not keep it for myself, but I'll invest it in an annuity, right? And so you make periodic payments. It isn't like section 2 where you just plunk all the money down once and for all, but no, let's say every month. So that happens to me. Let's say every month I take $100 from my paycheck and invest it in an annuity, and it earns a certain amount of interest, right? And so this is the same as section 2. The I is the periodic rate, okay, depending on whether it's monthly or quarterly or semi-annually, and N is the total number of compounding periods, right? So then you just throw it into this formula, right? So big difference between section 3 and section 2. It doesn't really affect how you do the problems, right? But instead of section 2 compound interest, you just plunk down, go to the banker and say, banker, here's my $50,000, now make it grow. Now, a lot of us can't do that, but we can maybe, since we're paid monthly. If you're paid monthly, I can take out, okay, I'll take out $100, $200 from every paycheck periodically and make investments that way. So rather than plunking down a big amount at one time, we can invest a small amount from every paycheck, let's say, right? And all the while, it's earning a certain amount of interest, right? So this is the formula that you're going to be using there. This is called an annuity. S is the future value of the annuity. Okay, never mind about this. R is the periodic payment. So you don't see P for principal. R is a periodic payment. You're making regular payments. 1 plus I to the n minus 1 divided by I. Okay, and this I and this n are the same as in section number 2. All right, so without further ado, I'll go straight to doing some of the problems. All right, so again, it was 5 through 12. You might find your numbers aren't the same as mine, or it might be offset by 2, or my 7 is your 9, or whatever, but you know, you're still learning the material. That's the main thing, okay? All right, so 6.3, again, ignore the dates. The dates don't apply. 6.36, or this is what I had for 6.36. Maybe it matches, maybe it doesn't, but you're learning the material. Okay, so you're given that R, the periodic investment, is $5,000. 10 years, you're investing 10 years, 9% compounded annually. Right? So what's happening here on a deeper scale is you're not plucking down a big amount right away. Every year, you're investing $5,000, it looks like. Okay? And you're doing that for 10 years at 9% compounded annually. Now, compounded annually is easiest because you're dividing the 9% by 1. So if you divide by 1, it stays 0.09. And furthermore, the n stays 10. 10 years, one time a year. That's annual compounding. So N is 10. All right. So your investment is $5,000 year one, $5,000 year two, $5,000 year three for 10 years. Okay. Which means the total amount invested was $50,000. As you can see, this was extra. But you don't plunk down the whole $50,000 all at once, right? Because maybe you can't do that. But instead, you say, okay, $5,000 year one, $5,000 year two, $5,000 year three, and I spread it out over 10 years. So that's how I'm investing the $50,000. So the total amount of the investment, yes, indeed, was $50,000 because it's $5,000 times 10 years. So it's $50,000. But you're not plunking it down all at once like in section 2. All right, so now we're just plunking everything down into the formula. So the future value, S, is the periodic payment, 5,000. Then it's 1 plus I. 1 plus I is 1.09, raised to the nth power, which is 10. Then by formula, subtract 1, divide the whole thing by 0.09. That whole fraction times 5,000. Okay? So if I can kind of show you the formula. I know some of you said, I'm never getting the book, and I can't read the formula. So again, I'll read it again, but hopefully you'll get the idea from the book, from what I have. So S, future value, is R. That's the periodic payment. 1 plus I to the nth power minus 1, all divided by I. Put that on your formula sheet. You don't want to memorize that. Okay, so how does that get applied here? So R is 5,000. 1 plus I, so it's 1 plus 0.09, 1.09, raised to the n power. N is 10. It's annual compounding, so you're not multiplying by anything except 1. Subtract 1, divided by 0.09. Okay? You always round these problems to the nearest penny. This is money. In the United States, we round to the nearest penny. And it comes out to be $75,964.65. And for most of your calculators, my advice is to do this part first. Save the 5,000 for later. Okay, so 1.09 to the 10th power minus 1. In fact, I'm going to show you what I do. And you don't have to do it all at once. I'm going to go slow. I'm going to go 1.09 exponent 10, subtract 1. Okay, so there's the numerator. 1.09 raised to the 10th power. My exponent button is here. Okay, and some of you have to use the button that looks like y to the x power. On this type of calculator, it would look like that, y to the x. On this calculator, this up caret, sorry, once in a while if I aim it wrong, I burn out your eyeball, so sorry about that, like that. And then subtract 1. Okay, 1.36, blah, blah, blah. Okay, that's the numerator. And now divide it by 0.09, so divide 0.09, okay, 15.19, whatever. Okay, and then times the 5,000. Okay, so times 5000, enter. And there we go. 75,964.648. 648 rounded off would be 65. So present your answer, always rounded to the nearest penny, $75,964.65. So that's my answer. Okay, so the main thing for these kind of problems is get the correct things down. That's the R. 1 plus I, 0.09, raised to the 10th power, subtract 1, divided by the original I, 0.09. Okay, so you can see right how I did 1.09 to the 10th power, and then I subtracted 1. Came out to be 1.36, blah, 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 divided by 0.09, 15 something, and then times the 5,000. Okay, do not round any answers off until the final answer. Okay, so in other words, don't top this up to 15.19. You'll lose some money. And don't change that to like 1.37. You'll be inaccurate. You want to get it accurate to the nearest penny, which is normally what's done in banks. I mean, you don't want to get cheated out of a couple of dollars, and so you keep every single digit if possible. Okay. So there we go. Now the problem's finished, but digging a little deeper, you might say, how much did I earn in interest? Okay, so what was the amount of my investment? I invested $5,000 a year for 10 years, so I invested $50,000. Look at how much it's worth by this scheme, $75,964.65. So the difference between these two numbers is my interest. Okay, I invested $50,000, but it's worth $75,964.65. So if I take this number and subtract this number, that's considered the interest, $25,964.65. So that's pretty good, right? That's the whole idea behind the investment. I want my money to grow. Okay, I invested $50,000, but it's worth $75,000 plus. Okay, so the difference is considered the interest, and yes, that would be considered taxable interest that you would have to report to the IRS and Franchise Tax Board for. That's considered income. That's a dividend income, interest income that you have to report. Okay. All right, so that's that. That was kind of easy because it was annual. If it's annual, you take the whole 9%, and n just stays 10. Okay, so now let's take an example like chapter in section 2, where you have different compounding periods. So question 8, which again may or may not be the same as yours, but again you're learning stuff. So the periodic payment is $3,000, and it's quarterly for 5 years. Okay, what's the new amount? All right, so every quarter you're investing $3,000. So $3,000 every, let's say, January 1, April 1, July 1, and October 1. And you keep doing that for 5 years. Okay, it's 6% compounded quarterly. So that means I take the 6%, which is 0.06. Don't leave it at 6. Don't forget 6% is 0.06. You divide it by 4. How do you know it's divided by 4? Quarterly. So that's 0.015. That's what you punch into your calculator. So 0.015 every quarter. So if every quarter you go 0.015, then the next quarter 0.015, next quarter 0.015, next quarter 0.015, that adds up to 0.06, which is 6%. So that's the little I. And what is my n? N is 20. How do I get 20? It's 5 years. And how many times a year? Quarterly, so 4 times a year. So 4 times 5, which is 20. So think of it, every year it's 1, 2, 3, 4. How do I know that? It's quarterly. So year 1, 1, 2, 3, 4. Year 2, 1, 2, 3, 4. Year 3, 1, 2, 3, 4. Year 4, 1, 2, 3, 4. Year 5, 1, 2, 3, 4. So the grand total is 20 because it was 4 times a year for 5 years. Is that right? Okay, now I throw it into that same monster formula. Okay, put it on your cheat sheet. S, future value, equals periodic payment, R, 1 plus I to the n minus 1 all over I. All right, so 1 plus I, 1.015 raised to the nth power, 20, minus 1 all over 0.015. Okay, and comes out to be 69,371.00 to the nearest penny. Let me try to verify that. Okay, so I did it before. Let me try to show that to you without burning out your eyeballs. 1.015 raised to the 20, subtract 1. Okay, so I'm only doing the numerator, the top. Okay, so 0.34 whatever, and divided by 0.015, divided by 0.015, and then times 3,000, so times 3,000. And there it is, 69,371.001. So yes, indeed, to the nearest penny, $69,371. Okay, now the question might ask, how much is the interest? Okay, so how much did I invest? All right, so $3,000 each time, 20 times, right? So I made 20 investments of $3,000. So how much did I invest? 3,000 times 20, which is $60,000. Okay, so I put in 60,000. What is it worth? 69,371. That's the whole idea behind the investment. You make your money grow. So the difference between this and this, you just subtract. That minus 60,000 is $9,371. That's interest. So the interest I earned on this account was $9,371. And yes, that would be considered taxable income to the IRS and Franchise Tax Board. Okay. All right, now so from twist. The next two problems are some twists to the problem. Okay. For number 10, my number 10, This time they're asking for the amount of the investment. You want to end up with $80,000 after 10 years, 8% semi-annual. So 80,000 is the left-hand side. 80,000 is the S. You want to end up with $80,000. So you're not plugging that in for R, you're plugging in for S, and you're trying to find the R. How much do I have to invest each time so that it will grow to $80,000? Right? So 80,000 is on the left-hand side. All right, so 8% semi-annual. If it's semi-annual, what's the I? Semi-annual means twice a year, so it's 4% or 0.04. Kind of messed up there. That's 0.04. And what is the N? 10 years. How many times a year? Twice a year. So 10 times 2 is 20. So I'm plugging 20 in. All right, so 80,000 goes over here, equals R times this great big fraction again. So 1 plus I, 1.04 raised to the 20th power, minus 1 divided by 0.04. Okay, this comes out to be 29.778 or whatever. Let me show you this. What you really want to do here is not round off. Okay, for greatest accuracy, you keep every digit. I'll show you how to do that. So first, let me see if I can give you this 29.778 stuff. So 1.04 raised to the 20th power. Oops, sorry. Trying not to burn out your eyeballs there. 1.04 exponent. Again, my exponent button is that. Or again, on this calculator, it'd be y to the x. And I'm raising it to the what? To the 20th power. Whoops. Guess I didn't do it. Let me clear it here. 1.04 exponent 20. And then subtract 1. Minus 1. And I'm dividing it by 0.04. Divided by 0.04. There it is, 29.778 or whatever. Okay, so it's 29.778 whatever times R. To solve for R, you divide both sides by 29.778. But you want greatest accuracy. Greatest accuracy is keep every single digit, which means you have two choices. Choice number one, get a sheet of paper and literally write down every single digit here. So you would literally write down 29.77807857858. Okay. Or on some calculators, you have something called answer, ANS. So if you have a TI type of calculator, it's usually way down at the bottom here. It's above the negative symbol here. It's answer key. That ANS stands for answer. It stores whatever the last answer was. Okay. To access it, notice it's a second function. So I would hit second function answer to do that. All right, now let me show you back up here. I'm trying to do 80,000 divided by 29.77807857858, right? So choice number one, okay, and sorry, if you have a regular scientific calculator and it does not have the answer button, answer key, sorry, you folks are stuck. You have to literally write down every single digit. I mean, it's a minor inconvenience. It's going to take you maybe, what, 15 seconds to do that? So everybody can do that. Okay. So again, greatest accuracy, do not round off. Once you round off, you'll be off by a few cents, maybe even a few dollars, and you know you don't want to do that. Okay. A way to avoid that, if you happen to have this answer button, and some of you have this, okay, is watch what I'm going to do now. I'm going to go 80,000, so 80,000 divided by, and now I'm going to hit second function answer. Second function answer. Okay, so I hit this button, second function answer. A lot of you have calculators that can do that. So please try that. By doing that, that's the same thing to the calculator as if I had typed out 29.77807857858. See, it's a lot faster. And there we go, 2686.5400. So round it off is 2686.54. Okay, so again, this is a very useful button, answer. For this calculator, I use it all the time. This calculator, unfortunately, doesn't have it. So you folks, sorry, you have to type out the entire thing, 29.778078078, whatever. Okay, don't round off until the very end. because you might be a little bit inaccurate. So the answer is this. All right, so that's the amount that you invest every 6 months, semi-annually. So in this scheme, what you're doing is you're investing this amount, 2686.54, every 6 months. And if you do that for 10 years at 8% interest compounded semi-annually, then you'll end up with $80,000. That's what it means. So it's a slightly different problem. And the problem's finished, but I'll dig deeper. What was the actual amount of the investment? So you're investing this amount each time, 2686.54. How many times are we doing it? 20 times. Okay. So I just simply multiplied 2686.54 times 20. And by the way, when you do that, don't keep this number. We don't have money that goes out that far. So I literally did 2686.54. You have to actually type that in now, because we don't have money that goes out to, 2629 right there. And take that and multiply it by 20. 53,730.80. All right, so what is that number? That's the actual amount of the investment. I invested this much. And how much did it grow to? 80,000 with interest. Pretty good, right? So I put in this much. It's now worth this much. So again, if you want the interest, just take the difference. So 80,000 minus 53, blah, 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 26 something. That's the amount of interest. Okay. All right, now number 12 is the hardest one, because you're asking for n this time. And I'm not sure if it matched. Let me see if I can find that. And yeah, it looks like it's my 14 here. But anyway, I think this is the book's 14. Yeah. But in the old version, it was 12. If $4,000 is deposited at the end of each half year in an account that earns 6.2% compounded semi-annually, how long will it be before the account contains $120,000? Okay, I think I have all the numbers. In the old edition, it was problem number 12. So I hope that's what you have. All right, so here's the game. You invest $4,000 semi-annually, twice a year, 6.2%. How long will it take for it to go to 120,000? So you're looking for n. All right, so I is 0.062, 6.2% is 0.062 divided by 2. How come it's divided by 2? It says semi-annual. So I is 0.031. Okay, so we got that. So this is a very different problem. You know the S, 120,000. You know the R, 4,000, and you know the I, but you don't know the N. So going back to the formula once again, I can find it again. This formula, you know S, 120,000. You know the R, you know the I. You do not know the N. So we're solving for that unknown N there. So right now, it looks like this. 120,000 equals 4,000. 1 plus I, 1.031 to the n power minus 1 divided by 0.031. I need to solve for n. Okay, so here's the progression. How do I get rid of 4,000? Divide by 4,000. So that cancels out. So 120,000 divided by 4,000 is 30. Okay, so now I have 30 equals 1.031 to the n minus 1 divided by 0.031. I got rid of the 4,000. How do I get rid of dividing by 0.031? I multiply by 0.031. So multiply both sides by 0.031. That cancels this out. I'm trying to solve for n. Okay. So that times that comes out to be 0.93. So 0.93 is 1.031 to the n minus 1. So now I have minus 1. How do I get rid of minus 1? Add 1. Plus 1, plus 1. Okay. So now it looks like this. 1 plus 0.93 is 1.93 equals 1.031 to the n power. 1.93 equals 1.031 raised to the n. How do I get that n down? Okay, that's where we take the natural log of both sides. So that's why we had to do natural log way back in the previous exam. Okay. Did you know that ln shows up in a lot of financial equations? That's why it's called natural log. It's a naturally occurring logarithm. So a lot of the formulas that you never see behind the scenes for interest and compound interest and all that behind the scenes, ln is there, natural log. Okay, by doing the natural log, that n gets to come down in front. See, I don't want that n floating up there. I want it to come down. So ln of 1.93 is equal to n ln of 1.031. Now I divide both sides by ln 1.031. You might not be able to see it here, but you can see it back at the top. N is 1.93 divided by ln of 1.031. So if you can't see it there, of course, you can always look at the video later. So n is ln 1.93 divided by ln 1.031. Okay, evidently, it comes out to be 21.54. Let me see if I can show that to you on my calculator. ln 1.93 divided by ln. Okay, so here's ln on my calculator. Okay. Or ln might look like on this calculator like that. There's also ln. Above ln is almost always e to the x. Okay, so where was I? Divided by ln 1.031. Okay, so natural log, ln stands for natural log or log natural, 1.93 divided by ln of 1.031, 21.537, blah, blah, blah. Okay, now again, some of you, when you hit ln, it automatically pops up with a left parenthesis. Okay, so if your calculator does that, you have to close it with a right paren. So 1.93 close paren divided by ln, and it pops up with that, right? So you have to close it after you hit 1.031, close parentheses. And there's the same thing. Okay, and let me talk quickly about this calculator. Okay, I tried to show you this in the video. This type of scientific calculator is backwards. You have to actually type everything backwards. So what do you mean by that? So for ln 1.93, for this type of calculator, you actually have to hit 1.93 first, and then hit ln, which over here looks like that. Okay, so that's the top. And then divided by what? So I hit divided by 1.031, 1.031, and then ln. And then I press equal. Tell me what I'm dividing by. And there it is again, 21.537. Okay, so your calculator might be backwards. You might have to hit 1.93 ln divided by 1.031 ln, and so on. Okay, now the last part is n has to be a whole number. These are number of compounding periods, the actual number of periods. You can't have a fractional period, 21.54. Okay? So the logic is you have to go up. Okay? Even if this were 21.01, you would have to go to 22. Logic being, after 21 periods, okay, you did not reach your target of 120,000. Now you're happy if you have more than that, okay, but you can't have less than that. Your target is 120,000. Okay? So if there was such a thing as 21.54 periods, you would have exactly $120,000. Okay? You can't have that, so you must surpass that. You actually have a little bit more, but you know you can't have less than that. So we round up to 22 periods. Okay? But the final answer says how long. How long is normally in years. 22 periods. So looking back at the original problem, it was semi-annual. Right? That means twice a year. So if it's twice a year, 22 periods, 22 divided by 2 means 11 years. So that's my final answer. And I want 11 years. All right? Okay, so I've done the even problems for 6.3. That's as much as I wanted to show you, which was 4 out of the 8. Okay. Now I'm going to go back and rapidly try to do some stuff from sections 1 and 2 for you from last time. And by the way, what I thought I'd do for Thursday's quiz, Okay, so quiz Thursday at the end of class. I'm just going to go ahead and give you the quiz that I was going to give you last Thursday, okay, which was on section 1 on simple interest. So it's a simple quiz on simple interest. All right, so that'll be the end of class on Thursday. Okay, but now I'm going to go back and show you that. Okay, and as I promised, I was supposed to show you the book, and I'm realizing my book and your book aren't the same. But anyway, at least you have something. So for those of you who never want to get the book, 6.3, here is my version of 1 through 6. Again, it may not match. And then we had to go up to 12 or 14 or whatever. Okay, so 390. There's 7, 8, 9. That should be enough time. And there's the rest. Okay, so again, if you need to look at the video later, just fast forward or rewind as much as you need to get the problems there. Okay, and I'm going to do the same thing for sections 1 and 2 now. Okay, so I'm done with what I was going to lecture in 6.3. Let me go back to 6.1 and 6.2 that I was supposed to cover last week. Okay, so 6.1, formulas that you need. So 6.1, page 362. Now I'm even doubting whether the pages are the same. So maybe the page numbers don't match either, but we'll see. Okay, simple interest. Interest equals principal times rate times time. I equals PRT. I is interest. P is principal. Rate is annual interest rate. T is time. It's always in years. And then 363. Future value. S equals P plus I. Future value is principal plus interest. Okay. And there are other flavors of it, other varieties. And that's all you need. Yes, the book has lots of other formulas like that and like that. You don't need any of them. Okay. But as I mentioned, there are variations of this formula. Okay. Let me go ahead and give you those variations again. I think I gave it to you before. So we have I equals P R T. S equals P plus I. Put these on your cheat sheet. Okay. But you will notice I'm allowed to put this right here. After all, I is PRT. So what if I put PRT here? So another formula, which is really the same formula, is if you substitute this expression right here, P equals P, whoops, I messed up, sorry. S equals P plus I, and I know I is PRT. And you can also factor out the P. Okay, so these are all the same formula. So that's what you needed for section 1. And in case, again, you're never going to get the book, 367. Again, my 367, 6.1. Here's the top part. See if I can get the bottom part. That should be it. Okay. And 6.2, compound interest. Only formula you need, 370, my 370. S equals P times 1 plus R to the nth power. Oh, I'm sorry. Well, that's sort of correct, but you actually want this one better. Sorry about that. Page 371. Yeah. S equals P times 1 plus I to the n. You don't really need this formula, although I mean, you can have it if you want. You're basically taking the interest rate and dividing it by something. And n is what they call m times t, number of compounding periods per year, times the number of years. So if you want to write it down, you may, but the only one you really need is this, S equals P times 1 plus I to the nth power. And yes, in the book, they have lots of other formulas out there. You don't need them all. Okay. I'll show you this a little bit later also, but table 6.3. Page 374, again, my 374. Number of periods per year. Annual is once, monthly is 12, daily is 360 or 365. Don't worry about hourly or each minute. Okay, I don't know why in this table they don't put quarterly or semi-annually, but I'll show it to you shortly. Okay, and then lots of other formulas. Don't worry about any of these other formulas. Okay, 6.2, again, my 6.2, my page 380. Okay, so there's that. And a little bit farther down. And I believe that's all we had, right? It's just 3 through 14. So, yeah, there we go. All right. So that's that. So somewhat rapidly, 6.1. I already gave you these notes. Okay, so you should have gotten the attachment. And I gave you a video on it, although you couldn't see the video, but hopefully you follow along with this. Okay. So my problem 2, 1,500 equals 5,000 times 0.05 t. This is interest equals principal times rate times time. So the interest was 1,500. The principal is 5,000. Interest rate is 5%. T is time. So I multiply these two together. 1,500 is equal to 250 t. Divide both sides by 250. 6 years. Okay, so it takes 6 years to get $1,500 in interest, simple interest. Okay, then my problem 4, 11,800 equals P plus PRT. And so notice I gave you that modification formula that I just gave you. Looks like this. S equals P plus PRT. P plus PRT. So 11,800 is P plus PRT. Factor out the P. 1 plus 0.03 times 6. That comes out to be 1.18. And divide both sides by 1.18. Comes out to be $10,000. So the principal was $10,000. Okay, part 6, or my 6. Principal is $800. Time is 5 years. Interest rate of 14%. What's the interest and the new amount? Okay, so interest, just plug in P times R times T. Okay, and by the way, on every quiz and homework and test, show all your work. I want you to show me the numbers and the calculation. And besides, that way I can give you partial credit. Okay, I mean, I can punch in the wrong numbers too. You can punch in the wrong numbers. I can punch in the wrong numbers. But if I see you have the correct equation, you got everything right, and you just punch it in your calculator incorrectly, I can give you partial credit. In fact, I can probably give you most of the credit if all you did was an arithmetic error. I can make arithmetic errors also. But if you just give me the answer and I don't see how you got the answer, what am I going to do, right? So show me your work. And besides, if you only show me the answer, maybe I'm going to suspect cheating, right? So show me all your work. So 800 P, R is 0.14 times the time of 5, and it comes out to be $560. Okay, S, what's the future amount? Well, it's the original amount, 800, plus the interest of 560. So P plus I, 800 plus 560, 1360 looks like. Okay, my 8, I think it matches your something else. Okay, they say principal is 1,800. Time is 9 months. 9 months is 3/4 of a year, or 0.75. Okay, so it said 9 months. So 9 months is 9 over 12, or 3/4 of a year, or 0.75. And the interest rate is 15%, 0.15. So remember, time is always in years. So if they give it to you in months or days, you have to convert it. Okay, so I equals PRT, 1,800 times 0.15 times 0.75, $202.50. Okay, that's the interest. Then what's the new balance? So it's the old balance, principal, 1,800, plus the interest, S equals P plus I. So 1,800 plus 202.50 comes up to be $2,002.50. Okay, then my problem number 10, You're given principal is 1,600, time is 2 years, rate is 14%. Okay. What's the new amount? Okay, so new amount, I can plug into P plus PRT, if I wish. Right? S equals P plus PRT. So 1,600 plus 1,600 times the rate, which is 0.14, times the time, which is 2 years. Punch it in the calculator, $2,048. Okay, then the last even one was my 12. Again, it might be your 14 or whatever. But in any event, you're learning something. The principal was 2,500. The time was 7 months. So 7 months means 7 over 12 years. Okay, that's not a nice fraction. Or it's not a nice decimal, I should say. So I'll just leave it at 7 over 12. The rate was 9% or 0.09. All right, so find a new amount. Again, I plug it in. This time I decided to plug it into this one, just for variety's sake. P times 1 plus RT. So 2,500, parentheses 1 plus 0.09 times 7 over 12. So I literally just did times 7 over 12. This comes up to be 1.0525. And then take that times 2,500, 2631.25. Okay, I'll show you what I did for this one. I actually did this first. So let me show you. 0.09 times 7 divided by 12. Okay, so 0.09 times the 7 and divided by 12. Okay, so 0.09 times 7 divided by 12. 0.0525, whatever. Add 1, and it's 1.0525. That's what I had there. Okay, so now I take the 1.0525 and multiply it by 2,500. So times 2,500, and there it is, 2631.25. Always round your answer to the nearest penny. This one's already in pennies. But let's say it was 0.257341, whatever. Round off to the nearest penny. All right, so that was rapidly through the evens from 6.1. Okay, and now I want to go over 6.2. What time is it? 6:30. Okay. So again, I know I'm going fast, but I'm assuming you had a look at my notes and maybe the video of 6.1 and 6.2. So I'm assuming it wasn't just all vacation last week. Okay, 6.2, compound interest. Right. So under compound interest, we take our interest rate and divide it into a certain number of equal pieces throughout the year. Okay, I'm not going to wait for you to write this down since I gave it to you before. You've already got it, hopefully, and you can always look at the video. Okay, so to save time, I'm not going to wait for you to write it down. You can do it later, or not, or never write it down. It's already here. Okay, so by way of example, and the book tried to show you this, but it didn't give you enough examples, in my opinion. Let's say you have 12% per year. Okay, so I can give you the whole 12% once. That would be annual compounding, one time a year. Okay, we're trying to find I and N. Okay. All right, so once a year, let's say January 1, 12%, plunk it down, here it is, goodbye for another year. Okay. That's how I'm giving 12%, if it's annual compounding. Right, so 12%, 0.12. Remember, you're changing all of these to decimals. So if it says 6%, you know you change that to what? 0.06. If it says 10%, that's 0.10. If it's 4%, it's 0.04, and so on. Watch out for that. Don't leave it as 12. It's got to be 0.12. Okay, now, semi-annual. Semi-annual means I take that 12% and chop it into two pieces. So 0.12 divided by 2 is 6% twice a year, or 0.06 2 times a year. Right? So the bank is saying, I'm going to choose to give you the 12% in this fashion. Twice a year, I'm going to give you 6%. So maybe what? January 1 and July 1. Quarterly, divided by 4. Every quarter. Spring, summer, autumn, and winter, right? So 3%. 0.12 divided by 4. So I'm going to give you 3% every quarter. That's how I'm going to give you 12% per year. Monthly, divided by 12. 12 divided by 12 is 1. So 1%. I'm going to give you 1% the beginning of every month. So 1% January 1, February 1, March 1, all the way. That's how the bank is going to choose to give you the 12%. Okay. Now, you can also do daily. The calculations are very difficult, so that's why we're not going to do any daily. By the way, a lot of compound interest is daily. Okay. I have an account that is compounded daily. So you take the 12% and divide it by 365. It's a very small number. So just for fun, 0.12 divided by 365. Very small number. Well, it changes the scientific notation. It's 0.0003 whatever. Okay, don't stress too much over what that is. It's 0.000328. Very small number. But you're getting it every single day, 365 times a year. Okay, so that's what's happening there. All right, so for my problem 4 and 6, which may not match yours, it might be your 6 and 8. But in any event, we'll see. So for problems 4 and 6, which may match yours, may not. Okay, it just asks for I and N. So 12% compounded monthly, 3 years. So monthly means you divide it by 12. That's easy. 12% divided by 12 is 1% or 0.01. What's my N? Well, it's 12 times a year. How do I know it's 12 times a year? It says monthly times the 3 years. 12 times 3 is 36. Okay. Notice that I and that N are the same I and N for section 3. In fact, it's the same for section 4 also. It's going to be the same all the way through. Okay, so that's nice. Okay, so that's what you can plug into the formula. Number 6, 10% semi-annually, 8 years. So semi-annually means how many times a year? Twice a year. So I divide by 2. 10%, 0.10. Don't use 10, it's 0.10 divided by 2. So my I is 0.05. My N is 16 because it's 8 times 2. All right, so rapidly do some of the other problems. Okay, and by the way, the last time I taught the course, I had 25. We said we're skipping 25, right? 25, so don't even look at that. I'm shortening the assignment a little bit. All right, so principal is 8,600, 8 years, 10% compounded semi-annually. Okay, please understand the scenario here compared to section 3. In section 2, I go to the banker, I plunk down $8,600 once and for all. Okay, here, banker, here's $8,600. I'm going to let it grow for 8 years at 10% semi-annually. That's all. I'm not taking any money out. I'm not putting any money in. Here's the $8,600. Leave it alone for 8 years. It's going to grow to this amount. Okay. Section 3, we're making periodic payments. So we're not just going to the banker and plunking down a big number once and for all. No, we're making periodic payments into this annuity. Okay, maybe it's a monthly annuity. I have a monthly annuity. Every month I invest $100 or $200 or something like that. Okay, so the big formula for this one, put it on your cheat sheet, was, where'd it go? This one again, right, page 371. S, new amount, equals principal, 1 plus I to the n. I is a periodic interest rate, and n is a number of compounding periods. S equals P times 1 plus I to the n. And I'm using it a whole bunch of times here. So S is 8,600, principal, 1 plus I is 0.05. Notice I don't plug in 10% because we're dividing it by 2. It's semi-annual. So 1 plus 0.05, 1.05, raised to the n. The total number of compounding periods is 16, 2 times 8. And that comes out to be $18,772.72, I guess. And let me see if I can actually get that for you. So again, I'll go slower for those of you who have a calculator that doesn't allow you to do it all at once. Okay, 1.05 to the 16th power. 1.05. Exponent, again, is this button for me. Raised to the 16 equals. Okay. Again, if you have this kind of calculator, You might say y to the x power. That would be this one. Don't round off. Keep all those digits. And what am I multiplying by? 60, where'd it go? 8,600. So times 8600 equals 18,772.72 rounded off. The next digit's a 1, right? You know the rounding off game. If this digit were 5, 6, 7, 8, 9, I would change that to a 3. And if it's a 0, 1, 2, 3, 4, I leave it as a 2. It's a 1, so leave it alone. Okay, you should not write your answer as 18,772.7214601. We don't have money in America that goes out that far, right? We can go down to the nearest penny. So to the nearest penny, 18,772.72. Okay. 10 is similar. What time is it? Okay, I think I'm okay. 10, it actually asks for the interest also. So principal is 6,300, 3 years, 12% compounded monthly. So it's monthly compounding. That means I divide by 12. And what's my I? 0.01, 1%, 0.01. N is 36. How did I get 36? 12 times a year for 3 years. So 12 times 3 is 36. Throw it in the formula. S equals P times 1 plus I to the N. I can write it here. S equals P times 1 plus I to the N. Maybe the book wasn't very clear. So there's the formula. S equals P, 1 plus I to the N. Remember, the I might have to be chopped up depending on the compounding period. Same for section 3, same for section 4. And N is not just the number of years, unless it's annual. It's the number of years times the number of compounding periods per year. Okay, so like if it's quarterly, you multiply it by 4 and so on. All right, so I established 0.01 and 36. So throw it in. The P is 6,300. 1 plus I, 1 plus 0.01, 1.01, raised to the 36, $9,013.84. Okay, and let me see if I can do this. Now, my calculator, you can actually type it all at once. So you're allowed to go slow, but if you want to go faster, let me show you on my calculator. If you type it all in at once, 6300 parentheses 1.01 exponent 36. And by the way, most calculators that can do this, it obeys the rules that if you don't put a symbol, it still means multiply. So in other words, I don't have to put a times symbol here. You're allowed to, but this knows just like, it's almost just like I have here, right? 6,300 parentheses means times 1.01 raised to the 36. Okay, 9013.8433, whatever, rounded off is 9013.84. And there we go. Now, it asks for the interest. Okay, so what was the investment? 6,300. What is it worth? More, $9,013.84. That's what you want. That's the reason why you invest with earning interest, then it'll be worth more. So the difference between how much it's worth, 9,000 plus, and the amount of the investment, 6,300, that's considered interest. So if I subtract 2,713.8, so $2,713.84 is considered interest, and that's taxable. You're supposed to report that to the IRS and so forth. Okay. And last one I was going to show you is 12. Again, it may not be the same as your 12. Okay, this one's a little bit different. 9% compounded quarterly. You want the amount to grow to $1.2 million after 25 years. Okay. Let me see if I can show you that quickly here. It might be the same as my 14. Yeah. Okay. So I think this is your 12. What lump sum should be deposited in an account that will earn 9% compounded quarterly to grow to 1.2 million for retirement in 25 years? Okay, I think that's the same problem. So after 25 years, you want 1.2 million. Okay, so that's not the amount of the principal. Okay, that's the new amount. That's the S. The S is 1.2 million. Okay, 9% quarterly. Quarterly means divide by 4. So 0.09 divided by 4 is 0.0225. What's my N? 25 years. Quarterly means 4 times a year. So 25 times 4 is 100. 100 total, 100 total periods is what I meant to say. All right, so I plug in 1,200,000 is not the principal. That's not how much you invest. Most of us can't invest that. I can't invest 1,200,000. All right, but you want it to grow to this amount. So if I'm going to have it grow to this amount, I need a certain principal, 1.0225 raised to the 100th power. Okay. Now, divide both sides by 1.0225 raised to the 100th. That cancels out. Okay. And now, this is what you want to plug into your calculator. Okay. So 1,200,000 divided by 1.0225 to the 100th power. And this is what it's supposedly going to come out to be. Okay, so let me actually do that for you. So 1,200,000 divided by parentheses 1.0225 exponent 100. Sorry. So 1,200,000 divided by 1.0225 raised to the 100th power equals, it is 129,673.005. So 005 means you round it to 0.01. So there it is, 129,673.01. And that's that. All right, so that's rapidly through 6.2 also. Don't worry about this anymore. I decided to throw it out because of what happened last week. What time is it? 6:45. Okay, I'm going to show you something from the last or the next section. There's one formula. So all I'm going to do is show you the formula and then I'll be done. 6.4. 6.5 is actually the same formula. So same formula for 6.4 and 6.5. What's a little bit harder for 6.5 is there's a table, and I'm going to show you what you need for that. Okay, so for 6.4 on Thursday, and yeah, I'll stop after a while on Thursday and give you the quiz. It'll just be on 6.1, simple interest. Okay, and again, it'll be due the following Tuesday. So hopefully it should be an easy 5 points for everybody. Okay, so 6.4, please. So I'll be done in just a few more minutes. Okay, it's something called present value of an ordinary annuity. I'll explain it more next time. It's on page 393. A sub n is equal to, again, ignore this. Okay, R times this great big fraction. It might be kind of hard to see. It's 1 minus 1 plus I raised to the negative n, all divided by I. Okay, so again, A sub n equals R bracket 1 minus 1 plus I to the negative n all over I. And I think what I'm going to do is I'll write it down for you also. Separate sheet of paper here. A sub n equals R 1 minus 1 plus I to the negative n all over I. Okay, so this is the formula. It's called the present value of an ordinary annuity. So AN stands for present value. This is on my page 393. Something called present value. Everything else is the same as today's section. R is a periodic payment. I and N are the same as the I and the N as last time. Okay, it's the interest rate per period, and N is the number of periods. Okay, so put this formula on your cheat sheet. Present value is R bracket 1 minus 1 plus I to the negative n, all divided by I. Present value of an ordinary annuity. This is for 6.4 and 6.5. 6.4 and 6.5. Okay. There's one other thing I want to show you for 6.5. You can get used to this already, so you can put this on your cheat sheet. So I'm going to jump all the way to 6.5, even though I'm not going to lecture on it until next week. But there's a table on page 406. So this entire table, I want you to have that entire table on your cheat sheet. Okay, this whole table is for something called amortization. You don't have to write that down now if you don't want to. Okay, but if you take out a loan, if you have to take a car loan, a home loan, okay, there's a table called an amortization table. Okay, I'll spell it for you next time, but oh, here it is, amortization. Amortization, payment or schedule. Okay, so period, payment, interest, balance, reduction, unpaid balance. You can have this whole thing on your cheat sheet, and you're going to have to come up with such a table during the exam also. Okay, section 5, it's the same formula. So the early part of section 5, which is next Tuesday, is going to be the same as Thursday. The harder part is how do you come up with this table? All right, so here's the table. Hopefully that's readable. I can kind of read it. It's a little bit blurry, but when you look back at the video, I think you can catch it. So have that entire table on your cheat sheet. Okay, so this formula is for section 4 and 5. Okay, so 6.4, Thursday, we'll be doing some problems with that. I might be able to sneak in some problems from 6.5 also on Thursday. It'll just help me because I want to spend a lot of time showing you that table on Tuesday. Okay, and I'll give you a quiz on Thursday. And in 6.5, same formula, but the harder part is how do you come up with that table that was there. Okay, so that's about it now, folks. So I'm going to stop the share. And let me look at the chat. What time is it? 6:50-ish? Okay, so chat, please. Check.
Yes, sir.
Okay, got that. Okay, Jonathan, okay. Thanks so much, Jonathan. You're a lifesaver. A lot of this. Oh, I think that's it. All right, so what time is it? 6:50-ish? Okay, so only about 5 minutes left. Does anybody want to ask something quickly? And if not, we can stop. Okay, I think I've given you everything. So I did 6.3, and looks like, I don't want to bring back, but I went back and showed you, 6.1 and 6.2. So Thursday, 6.4, and a quiz. It will only be on 6.1. I'm going to try to sneak in a little 6.5 on Thursday also. So then next Tuesday, we can work on 6.5, the table, and then the test on Thursday, the 24th. Okay, so any quick questions? Otherwise, we're done, folks.
I got a question.
Yes.
Can you please go over that 6.1 and 2 and 3 and 4, the assignments? Did you change the assignments on the homework?
Did I change the assignments? Yes, I did. Let's see. Yeah, I can't show it to you again here. It's going to take me too long, but I'll read it. 6.1 is 1 to 12.
Yes.
6.2 is 3 through 14, which means skip 25 and 26. And for now, 6.3, 4, and 5 are just as is. So 6.3 is still what? 5 to 12, of which I did the evens. 6.4 is 3 to 10, and 6.5 was 3 through 12. So that should be it.
So you only changed 6.1 and 6.2?
Correct. And the reason for that was because of the weirdness that happened to me last week.
Okay, thank you.
The assignment in the middle. Okay.
Could you repeat 6.1?
6.1 is 1 to 12, 1 through 12.
Thank you.
All, A-L-L.
No 17, no 18, right?
Correct. No 17, no 18, no 15, no 14, no 13.
Thank you.
I have a question, Professor Holm.
Yes, we.
Okay, exercise 6.2. In my book, number 3 to number 6, or to number 6, they have A, B, C, D question, including in each one of the number. So do I also answer all those A, B, C, D?
Okay, let me take a look. 6.2. I don't have it in my book, actually. Read quickly what it might say in A, B, C, D. I think I know. It just says something like, what is the interest rate The
Right.
annual interest rate and the rate per period.
And the length of the investment in years and the periodic interest rate and the
Yeah.
number of periods of investment. Do I answer A, B, C, D
Yes,
also?
that was sort of like what I gave you today.
Mhm.
It's easy for the interest rate. You just copy on what it says.
Yeah,
The only harder, quote unquote, harder part was to find the I and the N, right? So just divide by whatever you're supposed to. So if it says quarterly, just divide by 4, right?
right.
Find the N, you multiply by 4.
So we have to include that, right?
So yes, it's included, but it's pretty easy, frankly.
Okay. All right. Thank you.
You're welcome. All right, folks, it looks like we're out of time. So I think we're sort of caught up. We can do more. So next time I'll do 6-4, and there's going to be a quiz, and then the exam is going to be next Thursday. Okay. If I didn't catch you for attendance, send me an email, and I'll put you up there. All right. All right, so that's it. So have a good evening, everybody, and we'll see you on Thursday.
Thank you, you too.
Bye.
Bye.